Alright, we're going to look at the product rule. So the product rule is when you have two functions multiply to each other. That's the product rule, because it's a product. Now, if f of x is equal to g of x times h of x, then you take the derivative of the first one, multiplied by the other, and then you take the derivative of the second. This one's written in reverse, and this one isn't. Oh, this one isn't. I'll just show you what it is. It's pretty simple. So if g of x is equal to x cubed times sine sine 3x, find g dash of x. So I'm going to use the one on the right. So let u equals to x cubed, v equals to sine 3x. Then du dx is 3x squared. dv dx is equal to 3 cos 3x. So therefore, g dash of x is equal to, if I follow that one there, we want u, which is x cubed, dv dx, which is times 3 cos 3x, plus v, so that's sine 3x, times du dx, which is 3x squared. So then g dash of x is equal to 3x cubed cos 3x plus 3x squared sine 3x. Because it's an addition rule, you can just do it backwards, but this is useful for what's going to come later, which is the quotient rule. Alright, given that y is equal to e to the power 2x, x plus 1 all squared, find dy dx, and hence the tangent to the curve at the point 0, 1. So let's do u equals to e to the power 2x, v which is equal to x plus 1 all squared, and the u dx equal to 2e to x, dv dx is equal to 2 x plus 1, and then you take the derivative of the inside, which is the same. So therefore, dy dx is equal to, what are we doing? V du dx. So 2e to x plus 1 squared, plus u dv dx. So then we have 2e to the power 2x. I might just do it this way. 2x plus 1 squared e to the power 2x plus 2x plus 2 e to the power 2x. Now, I would usually not recommend you change the form, because if you change the form it gets a little bit more complex. And you also have to expand brackets and stuff, which is not nice. Anyway, and hence find the equation of a tangent to the curve at point 0, 1. So let's sub in 0. So we're at 2 times 1 squared e to the power 0 plus 0 plus 2 e to the power 0. Remember, anything to the power 0 is 1. So we get 2 plus 2, which is 4. So then the equation that the tangent will then be y minus y1 equals to the gradient, and then x minus x1. Alright, the graph of a function f of x is shown. Use calculus, find the coordinates where the gradient is equal to 0. Now remember, the gradient where it's equal to 0 would usually be the turning point, which should be that one. Sometimes it's not, but yeah. Find the derivative. so you should be familiar with it by now. You take the derivative of a second, multiply with the original, and then derivative of the first one, multiplied by the original of the second. And then you need to make this equal to 0. So we have x squared plus 2x times e to the power of x. Now, e to the power of x is always going to be greater than 0, because remember the function looks like this. And because of that, this can never be equal to 0, so all we need to do is solve x squared plus 2x equals to 0. So then factorize it and solve. So x is equal to 0, 0, and then also 2. So there you go, there's the second turning point. Now, at 0, 0 is 0, so that's 0, 0. See the graph anyway. At negative 2, we have negative 2 squared e to the power of negative 2. So then we get 4 e to the power of negative 2.